Hi, this is Lori, and this is my homework for Paul McWhorter's Pico W course, lesson number 22. In this lesson, we're going to be using our DHT11 temperature and humidity sensor and displaying the output from that sensor on an LCD display, the 1602. So I started the homework using the library that Paul showed us how to use from the SunFounder kit. And I did get the homework done, but I found when I tried to use the try and accept code, when I would go to leave the program and try to clear the LCD to screen, I found it very troublesome. It didn't often work, and sometimes it would, and sometimes it wouldn't clear the screen. I tried different ways of trying to clear the screen and got a little frustrated with it. So I did do the homework that way, but I also went on the search for another library perhaps that might have some better functionality and maybe a little more going on for it. And I found some tutorials on Tom's Hardware and a YouTuber named Nerd Cave. They used this library from Dave Hyland's, and I ended up using a version of it that Tyler Pepe had upgraded. And I just clipped a little bit from the GitHub page. So there's some nice discussion of how to use this library and a little more details about how it all works. So I left the link to where you would go to get that, and I'll put that in the description of my homework as well, just in case you want to try this library out. The nice thing about this library was it allows you to use some custom characters, and I remember with Arduino, one of the libraries I used allowed that too, so it's nice to have that functionality. And so they point you to this custom character creator page, which is intended, I think, to use with Arduino, but what you really need to do is to get this hexadecimal code for when you create this custom character. So I'm showing a clip of where I created a degree symbol, and then here's the hexadecimal code that will create that character, and you need to have it in hex for this particular library. So all you need to do is just copy out this piece, and I'll show you in my code how I incorporated that into my program. This is the code I used to use the SunFounder library with the DHT11. And so most of this code's pretty similar to the last homework, except for that now we're going to be bringing in the LCD from the library. So we'll use that function. We'll go ahead and set that up along with our button and our DHT11. And using all the same kind of code with the interrupt function, we'll use this toggle to go back and forth between degrees C and degrees F. Set up our interrupt request, let the DHT11 initialize, and I'm going to again use the tip from Keith on how to make our buttons more responsive. So I'll use that blink without delay approach. So we'll pick up our initial previous time measurement here, and then we'll do the initial reading to the DHT11 and print everything to it. So I'm using some F strings here to create the string I want to send to the LCD, and then here I'm sending that string to the LCD using the SunFounder methods. So that gets that started, and here's my try and accept, and then the while true loop. So here's the blink without delay approach. So we're going to wait every 2 seconds to do a new reading. And then I went ahead and did the print for the humidity to the LCD inside of this because I figured the humidity only changes when we do a new reading. Car passing, so wait a minute. Yeah, so no reason to redo the humidity every time we change the scale. I just leave that only being updated when we get a new reading. And then here's the scale toggle. So if it's true, then we're going to put the temperature in Celsius, and otherwise we're going to do the temperature in Fahrenheit if we press the button. So there we go. So that's the main part of the program. Then here's all my frustration you can see in trying to get this to cleanly clear out the LCD when I press Control C, and I tried using the clear function, and then I tried just sending some blank lines to it to get it done. And I printed to the shell just to make sure I was getting to this place, but these don't work reliably. The clear is the least reliable, and then these writes, they worked most of the time, and that's kind of part of what sent me to looking for that other library. Well, let's run this code. There we go. We got it in Celsius. We'll press our button, go to Fahrenheit, back to Celsius, back to Fahrenheit. You can see the humidity is really high today. It's raining here in Camp Baylor, so it's a great day for me to work on my homework. To use the other library that has the additional functionality, you do need to know your address of your LCD display. So this is some code that allow you to find out what that address is. So you just have to import pin and I2C, create your I2C bus from the pins that you have it connected to, and then you do this I2C scan, and this will print out all the devices found on that location. So if we run that, you'll see that's how I got the address of my LCD display. So that's the hexadecimal address. Here's the code that I used for the new library, and it's all pretty similar. We do have to import the files needed for that library. And again, I'll post a link, and there's a good description of how to put all that together in a nice test program you can run. Then you'll need to set up your address, and we just showed how to use the scan I2C function for that. Then the number of rows and columns you have. Then we'll set up the bus and set up the LCD using those variables. Everything else is pretty similar. And here's where we're going to set up our custom character. So that's the next different thing about this library. Allows us to use those custom characters, and from the slides I show you how I got this hexadecimal code. And then we're going to run the custom character function to make that character available to us. Then when we get to our initial reading, we'll do the humidity the same, except for we'll use the functions that are part of this, the methods that are part of this library. So we move to where we want to start putting our text, and we use putString method to put it on. Then we'll set up our Celsius, and we'll move to the 0 row, 0 position, 0 column. We'll put our text in place. Then at the end of that text, we're going to move to position 11, and then we'll put our custom character 0. So put character will allow us to put that degree symbol. Then we'll move one next position, and we'll put the letter C. So that'll get our initial humidity and temperature onto the LCD display. And then we're just going to use that same kind of code inside our while true loop to do the humidity every time we read. And then we'll do the Celsius just the same way, and the Fahrenheit the same way after we've done our conversion. And then we can exit the program using the clear function to clear out the LCD. Okay, let's run this one. All right. And there we go. Now we have a nice degree symbol. That looks pretty good. And let's go ahead and switch it back and forth. Yeah, that works pretty well. And I'm going to Control C so you can see it cleared the screen very nicely. No problems there. So this little more fleshed out library I think works a little bit better than the one we got from Sunfounder. So I'll probably continue to use this if I ever use these LCD displays again. Well, thanks. That's my homework. Thanks, Paul, and thank you for watching.